Next we have motion in 2 dimensions. So just bringing together some of the things you've been learning in the last few parts of the chapter. So we'll go straight on to example 8. This says we have a resultant force of 3I plus 8j. So that's 3 to the right, 8 up, 3 due east, 8 due north. Acts on a particle of mass 0.5 kilograms. And we want to work out the acceleration of the particle in the form of pi plus a qj, so in vector form, it's called vector form. The magnitude and bearing of the acceleration. Okay, so first thing we need to do is work out the acceleration using RF equals ma. So we've got 3, 8 equals half a. So simply if you double both sides, it's not a fraction, so you don't just do to the top, you need to do to top and bottom. So if we double both of these two, we get acceleration must be equal to 6, 16. So that's 6i plus 16j, but you can leave it like that, it's not a problem. To work out the magnitude and acceleration, magnitude and bearing of the acceleration, let's just work out the magnitude first. So we're going 6 across, 16 up. So we apply a bit of Pythag action. 6 squared plus 16 squared square rooted. Calculate a job for that. 36 plus 256 square rooted. 17.1. Generally we give answers to 3 sig figs, but were I to use this answer in a subsequent calculation, I would use the full answer. I only give you final answers to the required accuracy. What's another bearing as well? So I need this angle here. So this time I'm going to work out this angle here, just for a bit of variety, because those two angles must be the same. So the bearing is going to be equal to tan inverse opposite over adjacent, 6 over 16. So 0 to 1 or 0 to 0.6. Okay, example 9. We've got 3 forces acting on a particle of mass 3 kilograms. Find the acceleration of the particle. So we first need to work out the resultant force just by adding up the individual forces, which are 2i plus 4j, minus 5i plus 4j, and 6i minus 5j. So add those up. 2 minus 3 plus 6 is 3, 4, 8, 3, 3. And we want to work out the acceleration. So we know the mass equals 3 kilograms. We then use an RF equals ma. We've got that 3 equals 3 times a. So if you divide everything by 3, a must be 1, 1. Now, if you're not sure whether or not to give your answer as a vector or as a scalar like here, you can often tell by the amount of marks that are available, but also just work it out. I mean, it only takes a couple of seconds to apply Pythagoras theorem. So this means 1 to the right, 1 up. So Pythagoras theorem, square, square, add, square root. Which is just going to be root 2. I mean, this question didn't require that, but better to be safe than sorry. Okay, on to example 10. Okay, and we've got another 3 forces acting on a boat of 60 kilograms. And this time we're told the acceleration, work out P and Q, because we've got some missing information. So first, the resultant force is going to be the individual forces added together. So we've got 80I, 50J, 10PI, 20qj, and minus 75i, 100j. Don't bother putting the I there, didn't need that. Add those together, we get the result at 4, so it's going to be 80, 5 plus 10p, 50, 150 plus 20q. Now, its mass was 60 kilograms, and we know the acceleration is 0.8 minus 1.5. So using RF equals ma again from Newton's fantastic second law, we've got 5 plus 10p, 150 plus 20q must be equal to 60 times 0.8 and minus 1.5 for the acceleration. So we need to do 60 times that and 60 times that, and not just the top, it's not a fraction. So it's going to be, what, 48 and minus 90, I think. So that gives us two equations. 5 plus 10p is 48. So 10p is 43, p equals 4.3. And along the bottom, 150 plus 20q equals minus 90, giving us 20q is minus 240, meaning that q is minus 12. So there are values for p and q. Okay, that's everything up to exercise 10D. So crack on with that now.